Hello, everyone. Morning.
Hello.
Good morning, everybody.
Hi. Um, um, it's, it's been a little bit early. Let's give people maybe another minute or two to join in. So today we're continuing the discussion with Karen's presentation. I think last time we were only able to go through a couple slides and have to discuss because I think this presentation is has many information in it, and we should talk a little about more. I'm wondering, does anyone know if there's a there are people working on the standard for LPO transceiver, or still a fairly untouched territory?
Well, I think Jeff can talk to the OIF work.
Yeah, I mean, there's an LPO MSA, and there is the CEI linear work at the OIF. Those are the two efforts that I'm aware of.
Oh, they're all based in OIF, or this
No, the
MSA?
MSA is an industry organization. I think,
Uh-huh.
basically initiated by Arista, if I understand it correctly. And then the CEI linear came before those things. And they're doing the 112 and the 224 linear interface.
Mm-hmm.
So what they're doing is they're specifying electrical standards at TP1 and TP4,
But here, that's how we've had.
and adopting the optical things at TP3 and TP4 from IEEE, is my understanding.
Oh, I see. Good. No, thanks, Jeff. All right, so I guess we can start it. Karen, do you want to share the slides again, or
Yeah,
I can share it on my side?
let's see if I can share. Let's work. Are you seeing it? Yep. Do you see it?
Yes, we can see it, but Karen's, your sound is a little bit fade to me.
Oh, my
Maybe
sound.
your microphone is probably away from you.
No, I think the setting of the microphone is low. Hang on.
Um, you okay? Um, Karen, are you able to get your voice back? Karen, do you want me to share the slide? Great.
Okay, can you hear me?
Yes, now it's loud and clear. Thank you.
Now I can't hear you. Um. I'm just using the computer speakers now. All right. So you can see this. I'm gonna go to the next page.
Yes.
Yeah. So, okay, I don't know which page we wanted to discuss.
I think last time we're kind of pausing here, right? And I think we're probably the next slide is the one that we stop. Because you know, about the existing powers and in other form factor.
Yeah.
In
Yeah,
Go
and so I did get some comments afterwards, that the pricing's very high that I show here, and this was on purpose. I think I told I told you guys on the meeting, but the people not on the meeting might not have caught that this is like single unit on the web. And so it's not volume pricing.
right.
But the relative, I thought it was representative, like the relative positioning.
Yes. And this is for existing 100G cable.
And this is for existing 100G because you can just go on the web and find this, right? And
Mm-hmm.
yeah.
I-
And even if you were to get ASPs, I was saying that the problem with ASPs is the relative volumes are quite different in practice, particularly between ACC and AEC, where, you know, as these are new product categories. And so even actual volume pricing doesn't, to me, represent the technical potential for what volume pricing would be for each category, because they're not in equal volumes, you know, in practice.
I totally agree. Do you foreseeing in 200G or something that AOC will probably stay around the same price?
I think historically, prices have, I think historically prices have met the previous generation's pricing. But it certainly gets more difficult with each generation. So, you know, at 200G, and that's eventually, I would say, when it's mature. So certainly it may take quite a long time, I would think, for 200G to become really mature. And I think, Jeff, you've probably seen this as well, right? That, you know, I think we've seen a lot of, you know, quite many years, but I think, you know, there was a presentation that I saw at IEEE or something, I think from Cisco, that talked about the technical progress of 100G over, I believe it was 6 years. And, you know, the performance certainly improved a lot, and I'm sure that the cost did too. And so there's a question of also of timing when you look at cost.
Yes, yeah, I totally agree.
So you know, probably the expectation on the customer side is that asymptotically, I would say you hope that, you know, you get twice as much for the same price eventually, but this is asymptotically, right? So, I mean, we could look at it in those terms. as a target, right? I think, you know, so one of the questions is, you know, in this body, we could talk about ecosystem expectations and a target, and then what the challenges would be, you know, maybe that's the way to approach it with something like both power and cost, right? There's an evolution over time, and cost is particularly difficult because it's not a technical issue purely.
Yes. Yes, and I think in your tables, even in 100G, the AEC shows similar the amount of power compared with the AOC, and that means that's already like at least like one game they're tied at least for now.
Yeah, to me, that was the surprise, I have to say. You know, I didn't expect that. I mean, clearly it also depends on what type of AOC, right? I mean, but yeah, I was surprised actually, and I thought that was very good for optics.
Yeah, right. Well, we were saying
I think the challenge is always that I don't know to what extent the ACC and AEC, in particular the AEC, I don't know to what extent it has the potential to benefit from silicon process nodes, right? Which may affect it more than the optics over time. So, you know, there's I just don't know if people could go to the next process node and lower the power in the AEC more easily than they can lower the power in the AOC over time.
true.
So, I mean, I could say kind of what, you know, how we thought about this at the OIF.
Mhm.
So we asked the hyperscalers to comment on it. Some did. And the term we came up with is they'd be willing to pay double the cost of copper for the optical connection, because it saves a lot of, you know, weight and space and various other kinds of things. Um, and I think, you know, they didn't say this explicitly, but I think they would, of course, use copper for any short lengths where they can use a DAC. And then when they had to go to the next rack, right, then that's when they would switch to optics. And then that was sort of the cost targets, like how much first there's some convenience they get out of using optics, and you know how much are they willing to pay for.
Do you feel, Jeff, that that's implicitly 2x DAC or 2x in active copper? Because those are quite different based on the numbers.
My understanding of that stack, Aaron, you know,
Yeah.
maybe I interpreted that incorrectly, but that's my understanding.
Yeah, that was my understanding too, which, you know, is still kind of a big gap, I think, for optics.
Right. Mm-hmm.
So Jeff, were you saying I didn't catch that gap part? Is that most people would stay with the DAC instead of the ACC or AEC?
Well, if you think about it, if you're going to only go a meter
Mm-hmm.
and use copper, and we're talking, you know, 200G and below data rates, not 400G. Who knows what happens at 400G, but 200G and below, if you go a meter, then, you know, it's possible to build that system. Yeah, the copper cables, there's a lot of them and all that stuff, but inherently they'll be more reliable than the optical device. Optical device will have a lot more parts in it.
Right.
Right.
Definitely.
And so if you're going to build a system and you only have to go a meter, why would you burn additional power and pay extra money to do that? Now, if you need a large cable to go between racks or up to some switch or something longer than a meter, you can use an active copper cable, which will burn more power, or you can have the flexibility of putting an optical cable, and you can go additional different distances. I'm not saying that no one would use an active copper cable. You know, but I'm just saying that the switch point between DAC and optics will occur, you know, once you go beyond that reach for copper, which is about 1 meter for DAC at 200G. And then they're saying that if you do that, then the, you know, the cost target is 2x that of copper.
I see. Cost target is around 2x.
Well, they want to be under that, obviously, but you know,
Yeah,
that was the guidelines that we got.
I think this is fairly useful information. It's like, you know, cost target.
Mhm.
I think it might be useful if, I mean, Karen, you said that these prices are from the web. You want to try to put a row on this, which is nominal market pricing?
I mean, I state here that volume pricing that I've heard or seen is 2 to 5x lower, and I said the caveat is, you know, the inputs I got varied by that much, and I think that some of it is, I mean, you know how pricing is, right? It's very situational, as well as volume dependent.
So Karen, we
You
could
know,
do a quick,
I didn't feel comfortable giving a more firm number than that, simply because the inputs I heard varied literally by that much, you know, and so I just gave the guidelines of 2x to 5x lower.
Karen, I could do a quick sanity check on the $500. What is the, how many gigabits is that?
These were all for, basically it was a 16 by 100 gig equivalent. So this was, 2 OSFP ports, 2 OSFP DACs at maximum reach of 3 meters. Because of course, for copper, you're literally paying for a massive amount of copper as well. So the pricing varies with length.
And when you, yeah, okay, got it. So basically I would agree with
So
Karen.
250 for a DAC, right? I mean,
I just did a sanity check and I would probably think that she's right. It's somewhere around 5, at least 5x or a bit more lower for that.
Right.
Is what-
I mean, if I'm just saying, I'm just trying to be helpful, but people tend to look at numbers and they get fixated in their head. So maybe
Mhm.
just put a row on here that says volume pricing and divide by 4 or something like that. Or put a dollar, put a cost per gigabit or per terabit.
Mhm.
I mean, it just people this 5,000 seeing a number of $5,000 for an AOC is just counterintuitive.
Mhm.
So it may make people just dispel this chart as is just wrong.
Well, what we do know is for a long time, the industry is trying to get under $1 per gigabit for optics.
Sure.
And
Yeah.
so that's at least a reasonable upper bound, you know, and
Yeah.
so, yeah, I agree with you.
I would just put a row that says estimated volume pricing or whatever.
yeah, I think that's a good idea. I think though, perhaps we as a group should come up with that instead of just me.
Mm.
I mean, I guess I could do this and revise the chart if you want, but yeah, I mean.
Yeah.
To the extent that people, as Mike says, fixate on it, I think I would like that to be something we agree on as opposed to something that I've just thrown out there. So, you know, I can chat with you guys offline if you want me to.
Should we move on to the next couple slides? Yeah, so I think these poor things is just aligning the idea for the more pin things.
Yeah, this is just the point about, connector styles shared between optics and copper, and that it's beneficial. So
Yeah.
I think this is not as incontroversial as it might seem, right? I think Jeff had mentioned that he felt that CPO struggles with the fact that it tried to be the same as CPC. I'm not sure if I misunderstood you, Jeff.
I'm trying to recall exactly what my comment was. You're saying that, oh, I think I know what I was trying to say. So maybe this is it. In the OIF, they defined the 3.22T form factor for co-packaging,
Mm-hmm.
and what the Ethernet side use case wanted was interoperability between that and copper cables. So they wanted to be able to have a copper cable that would go on the co-packaging platform. The problem with copper cables is there is a minimum, gauge size and everything else. There's a minimum connector footprint. So in order to make a socket, a footprint that would accommodate both copper and optics, we had to make the footprint for the footprint a lot larger than it would be for optics alone. I think that's what I was trying to say, Karen. Does that sound
Yes,
right?
I think that's right. That's right. Yeah, so that this having a common form factor is a good goal from a usability standpoint. The caveat being if it restricts the performance in some way, density being a performance metric here, I would say, that would obviously be a handicap. So I think I think it's probably not controversial that it's a good goal, and it's just a caveat that it may not be possible. And you don't want to end up with least common denominator in such a performance-driven application, I think is the takeaway.
Yeah, I think I think this would be very interesting part, because I'll probably talk to you, Jeff, about this offline to just try to understand a little bit more.
Yep. Okay.
Thanks. Should we move to the next one?
So, this is a lot of words, right?
Yeah.
And this is just that,
Yeah.
and again, that there is in fact this interest in a new definition of a higher density
Right.
approach. And I think, yeah, that there's OIF activity, right? So I don't think we need to, this is again, just
Same.
motivation and feasibility, right?
Mhm.
And this articulates that the current target is scalability to 400 gig, which I think is a relatively new target that's been introduced into the discussion and has, I guess, taken the discussion in maybe a slightly different direction than it might have 6 months ago. I don't know, Jeff, if that's your impression.
Well, certainly the industry is interested in what the next thing is up in many years out, but certainly they want to be able to scale it to 400G. They'd like to get more than one generation out of the solution. And today the state of the art is 200. So one more generation would get you to 400 or whatever that's going to be.
And I think that the rest of the slide is really saying that there's two density metrics, one being reference to the ASIC escape and the other being reference to the front panel density, and those are two different density metrics.
Mhm.
Yes.
You know, Karen, and on this picture you've got, one thing I was just doing some back of the envelope calculations. And you know how you have the host ASIC and then you have two deep, the interface blocks. And I don't know if your team has looked at that, but when I looked at the routing to escape it out of the ASIC and get all the traces over there, that seemed exceedingly difficult. Like, I don't know that I would try that.
Yeah, I mean, I think the intent here was not necessarily the figure with the number of interface blocks.
I mean, it's just too many lines to bring through the substrate and maintain some decent signal quality, signal integrity. That's what I worried about when I saw this.
Yeah, agreed routing is very challenging. Yeah.
Yeah.
Agreed routing is extremely challenging. I think in the context of this group, I wouldn't, I mean, it's, I don't think, I think this is a very general figure, and one thing that I think one possibility is one way you can actually interpret this is you could interpret this as a double row, which is what Peter Windsor has espoused. The other way you could interpret this figure very generally is you could imagine that these are different chiplets, and the first row could be some kind of chipletized SerDes, and the other row is something that actually contains the optics, right? There's different ways to parcel this out, and I don't think we are necessarily going into want to specify anything in this group, right? I mean, we've kind of said, I mean, I've seen cases where the SerDes chiplet is actually the density limiting piece, right? So either of these blocks could be the density limiting piece, and we have to be aware of that.
Is it okay if I show a slide from the recent 400G workshop? It's right before the design con.
Yeah.
It's from Meta, but I think the information is relatively public. It may be relevant to the discussion here.
Yes.
Let me try to do this.
Well, I think it's the design con this year is very interesting because it used to be mostly just a board level design, but now this year it feels like a lot of optics and other things involved.
Because by the discussion about 400G started really not that long ago, but it feels like quite a while. It's last year I heard a lot of noise. And this one actually is from Meta, and as I mentioned, is in the 400G workshop hosted by Sina, the SFF people.
Mhm.
So there's one slide that I want to show is this one. So this one, they actually talk about the evolution from the current 224G to 448. And this here is interesting, that caught my eye. So in both cases, for this forum, it's probably more relevant to think about this one, the red one here. But then inside the rack, or on the tray, I should say on the tray, inside the tray, they're talking about just using a CPC. The internal cable is still copper. It makes sense to me because even at 400, it is possible to do a CPC maybe around not 1 meter, but 1.5 feet. That would be half a meter. Half a meter internal cable, which I think is doable. And then go to a pluggable. Here is the electrical to optical switch, which people are doing today. So this seems to be a clean solution. then and it also avoid the problem of CPO being less reliable to CPC. So if you need to service a co-packaged connector, it's not desirable. You need to open up the rack, you need to pull out the tray, and yada yada yada. So this may be something worth thinking about.
Hi, this is Raymond, right?
Yeah.
This is Ryan from TerraHop. So we actually advocated some very similar ideas. If you look at the OIF high density connector proposals, I think this is a good path to implement a pluggable, but with very controlled channel loss, right? You can actually just use CPC with cable and then to the front panel. So I think this is a good idea. So I support your suggestion here.
Well, I'm not suggesting anything really. It's just showing something I have seen that may be relevant.
Yeah, no, I think this CPC concept has been already implemented in demonstrations in systems, and so I think it's one of the options I think we should consider.
Okay, so let me stop sharing. And by the way, it's again, it's the Meta slide deck. If anybody should be able to access it if they are part of the work group.
Yeah. Great.
Yeah, that's great.
I think we're about time. I know people has to probably switch channel to other meeting. Thank you everyone for the participation, and we'll see you next week.
Thanks.
Thank you.
Thank you.
Bye-bye.
Bye.